Okay, so the next couple of problems are associated with circuits. And they're just circuits that are open or closed. And so we're going to do problem 91. And if you have two switches that are in series, that means they're connected to each other from end to end, then you can use an AND statement. And if they're in parallel, then you use a OR statement. So in this case, we have a switch here for P. We have a switch here for Q. Comes over here. So these are in series because they're connected end to end. And these are in parallel. And then we come out here. So this is P, this is Q, this is P, and this is not Q. So we do these separately. We combine these two elements. So the top element is going to be P and Q. And the bottom element is going to be P and not Q. So when you combine these two, then you come into a parallel situation. So you can go either path. And when you have parallel situations, then you have a union. So that's the equivalent. Now the question is, simplify each circuit when possible. So the question is, how do you simplify this thing? And I think that's right. We go to this table on page 106, and so if you look right there at P and Q, so it's the second one down, P and Q, and then you have not P. So that's equivalent, this would be equivalent to P and Q, but Q, so we have Q in union with R. This is R in an equivalent statement, so that's not Q. Well, Q in union with not Q is basically everything. And then you have everything, so this is all, if you want to call it that, in union, in intersection with P. So P, including this, includes everything. So all you have left is P. So that's your simplification in this particular case. Okay, let's go to the next one, which is we're going to do 94. And so we have a circuit, and we have a switch here, which is Q. And then we have on the bottom side we have P. And then we come to this one, which is parallel, and that's Q and not P. Comes over here. And this goes like that, and that goes like that. We come out. And this one is P, and this is Q. So you start at the kind of the most distant part. So we have two parallels here. So these are in parallel, so it's going to be Q or not P. So that's what this part is here. Now, then we have that in series with P, so we can do P and Q. So we have P and whatever this is, and that's Q or not P. And then we have these two in parallel. So this is Q. Parallel means OR, so we can do OR P and Q or not P. Let's make sure I did that right. Okay, so that's right. Now, as far as simplifying this, let's go back to page 106 and see if we can do anything here. So So I think if we take this inside part and okay, let me just pause here for a second. Okay, I've looked at how to resimplify this, and I've decided that it's just not worth going through. There would be very few people that would understand what I was doing, so I'm just going to punt on that one. And so let's just do one of these where you're given a statement and come up with a circuit. So let's look at 97. So we have P intersected with Q union not P. So we start on the inside and we have a union, so that's a parallel circuit. So we create a parallel circuit like this, and we put Q here, and we put not P there. So that's what that part is. Q union with not P is the same as Q in parallel, and then we connect it in series, so we have another switch that represents P. And so this is the equivalent circuit that would work out. And we'll just do one more. Let's do 100. So we get not Q intersected with not P, union with not P, union with Q. So let's look here what we have. This is a series comment. This is a union, so it's going to be in parallel. So let's see if we can do this right. So we have this switch and this switch. This is not Q, and this is not P. And because they're in series, it's an intersection. Then we have a union, which means it's in parallel. So we have this, but then inside this one we have another parallel thingy-diggy. So we have that, and we have that, which comes over here, and then goes like that, and then comes out. And so this one is not P, this one is Q. So when you do these two together, you get the series, which is AND. And then we have this inside thing is not P union with Q, so it's a parallel. And then these are in parallel, so we can then put a union between the two. So that's how that one works.